Good morning friends, myself Dr. Parisha Lande, Associate Professor VPKBIT Baramati. Today topic of a presentation is acceptance sampling and the subject metrology and quality control. So what is acceptance sampling? Acceptance sampling is the process of evaluation a portion of a product material in a lot for the purpose of accepting or rejecting the lot as either conforming or non-conforming to a quality specification. So acceptance sampling is defined as a sampling inspection in which decisions are made to accept or reject the product or service. It is a decision-making tools by which a conclusion is reached regarding the acceptability of a lot or acceptability of a sample. Acceptance advantages of acceptance sampling. Acceptance sampling eliminate or rectify the poor lot and improve the overall quality of product. It also reduces the inspection cost as well as the producer and consumer risks. In inspection of a sample, greater care will be taken so that the result may be the more accurate. A rejected lot is frequently a signal to the manufacturer that the process should be improved. It provides a number of alternative plans in which a single sample is taken. Two or indefinite number of sampling may be taken from a single lot. Sampling plan. So basically the sampling plan is of two types. First is the attribute sampling and second one is the variable sampling. In attribute sampling, first is the single sampling plan, second one is the double sampling plan, third is the multiple sampling plan, and fourth is the sequential sampling. So attributes sampling plan. Attribute sampling plan is the most commonly used. More than one type of quality characteristic can be considered for each sample. So measurements are simpler to make and it requires a larger sample size than a variable sampling plan. Single sampling plan, a plan in which inspector is forced to make a decision concerning the acceptability of a lot or batch on the basis of inspection of a unit in one sample taken from that lot. So it can be described in terms of three constants. Capital N indicate the lot size, small n indicate the sample size, small c is the acceptance number, and c is the maximum allowable defect in sample. So if a sample contains c or less than c defective, lot will be accepted, and if it contains more than the c, lot will be rejected. So in case of the single sampling plan, the acceptance of the lot as well as the rejection of the lot depends upon the number of c. So whatever the number of c that is decided, if suppose c is equal to 3, and in that case the number of the defect is equal to 3 or less than 3, that means that sample accepted. But if the number of the defective or number of is that more than c, that means more than 3, that is 4, 5 or 6, in that case the lot is rejected. Double sampling plan. So in case of the double sampling plan, the acceptance as well as the rejection of a lot or depends upon the two, that is C1 as well as the C2. So these are the characteristics by the two sample size along with the two set of acceptance rejection numbers. So two sample size may or may not be equal. It can be described in the terms of C1, C2, N1 and N2. So next, a multiple sampling. So in this, 3 or more sample might be taken before a decision is reached regarding the acceptability of a lot, and it results in a smaller average sample plan. Sequential sampling. So in sequential sampling, an extreme case of a multiple sampling in which a sampling might continue until the lot is exhausted. It calls for the inspection on an atom by atom basis and decision is made after each item is inspected concerning whether the lot should be accepted or rejected or sampling continue. Sampling and decision making continuous until a clear-cut decision is obtained either to accept the lot or the reject the lot. So in this case, the sequential sampling, there is a continuous process of checking the part up to the result. So that's why this sampling is called as a variable sampling. So variable plan need the measurement type, data and decision must be based only on one such a measurement characteristic. It is efficient because variable carry more information than the attributes and based on mean and standard deviations characteristics. They are difficult to use. Next, operating characteristic curve. So the curve which serve to describe an acceptance plan in terms of a probability of accepting lot of a various quality level with the plan. So in case of operating characteristic curves, PA is the probability of accepting the lot and P dash is the actual proportion of a defective. So now see the diagram of the operating characteristic curves. The operating characteristic curves in the x-axis as well as the y-axis. In case of the x-axis, that shows the indifference zone, that means the rod, and the y-axis show the probability of acceptance. So now in x-axis, that is AQL, that is LTDP. Then in x-axis, that is the beta, that is called as a consumer risk, whereas the alpha y-axis, that is called as a producer risk. Operating characteristic curves, y-axis gives the probability that the lot will be accepted and that is represented as PA. X-axis is the P and that is percent defective. Show the percentage defective along the horizontal axis and the probability of acceptance along the vertical. Now see the various nomenclature used in operating curve. So that is the different definitions of variables. So PA, that is probability of acceptance. P, that is proportion defective. Capital N is the lot size, small n is the sample size, small c is the acceptance number, alpha is the producer risk and beta is consumer risk. So now see the uses of a operating characteristic curve. First, selection of a sampling plan. It helps for selecting a proper sampling plan, that may be the single, double, multiple, sequential or variable. Second, adds in a selection of a plan that are effective in reducing the risks and keep the high cost of inspection down. Thank you.